Hi. So, today in this little video, I'm going to give you a short talk on the concept of compartmentalization and the importance that it plays in the function of cells. Right? And so the concept of compartmentalization is pretty straightforward. You have different areas that are self-contained and they have individual responsibilities. And so if you think of a cell in and of itself, right, that cell is an example of compartmentalization. Right? The internal environment of the cell is different than the external environment, and the two things are separated. Right? The cell itself has a job to do, and so it needs to be separate from the outside environment. In eukaryotic organisms, this concept of compartmentalization is taken a step further with the addition of membrane-bound organelles. Each of those membrane-bound organelles, such as the chloroplast or the mitochondria or the nucleus, are their own self-contained areas with their own individual roles. Right? And so those roles have individual unique needs. The mitochondria is going to need different enzymatic materials than is the chloroplast. Right? And so by having these discrete areas where you can affect the concentration of those materials without impacting the entirety of the cell or without crossing together, right, increases the efficiency of those cellular functions infinite-fold, not infinite-fold, exponentially. Let's say exponentially because it's not infinite, right? Just by a real big amount, huge amount of increase in efficiency there. Right? And so the analogy I like to make is if I have a hot dog factory, right? I have my hot dog makers in the hot dog area, and I have my accountants up in the accounting area. And so my accountants are typing away on keyboards, doing maths, and my hot dog workers are slapping together the hot dogs and the buns. Right? I don't want a bunch of computers in the way of my hot dogs, and I don't want a bunch of hot dogs in the way of my computers. So I compartmentalize my hot dog factory, and I keep the computer nerds up here, and I keep the hot dog slappers down here, and everybody can make a lot of progress on their work a lot more quickly than if they were in each other's way. Right? And so the cellular functions work the same way. If you have the mitochondria doing mitochondria things with mitochondria materials, it works a lot better if the chloroplast materials aren't getting in the way of those jobs. Right? Furthermore, another additional benefit of compartmentalization is that the addition of those membranes allow for more surface area for chemical reactions to occur, right? And in cells like the mitochondria, you see a lot of folding in those membranes, even adding more surface area. So you can have more efficient work, you can just have more work going on. It's just a better system, right? Within the story of compartmentalization is offered a good opportunity to discuss the process of endosymbiosis, which is the process under which most of our eukaryotic organelles have arisen. Right? And so the idea of endosymbiosis is you have this larger, more complex cell, the eukaryotic cell, and it has a lot of space, it has a lot of complexity, right? And it has other organelles going on. And it encounters a simpler, smaller prokaryotic organism, right? But that organism has a unique skill set. And so if we pretend that this organism is destined to become the mitochondria, right, this organism was able to do oxidative phosphorylation to do cellular respiration the way that we utilize mitochondria now. Right? So we had this big cell met this little cell who had a really cool talent. The little cell went inside the big cell. They had a happy union because now that little cell has access to more materials. It's safe and sound inside of that big cell. And now that big cell can reap the benefits of that oxidative phosphorylation that that little cell is doing. Right? And so over the course of time, as they divide, they're dividing together, right? So the big one divides, the little one divides, and they're dividing together. And eventually, the little one ends up losing its individual identity and just becomes this organelle of this larger cell. And that's endosymbiosis, which is a really sweet, cute little process by which we get cool things like mitochondria and chloroplast. Right? So that's why mitochondria have their own DNA still, because once upon a time they were their own little cute organism swimming around the world, just looking for friends. So yeah, that's it. Bye.